So in Edgenuity, they talked about several different types of equations that you see, and they talked about sometimes you end up with a precipitate where we have a solid that's formed, sometimes you have a liquid that gets formed, and sometimes nothing gets formed. It stays aqueous. So what I wanted to talk to you about today was why and how do we know? How do we know if it's going to stay aqueous after we mix them, or if it's going to form a precipitate? Okay? And they did some net ionic equations. So let's start with this first example with silver nitrate and sodium chloride. When we put those things in water, we end up with silver ions plus NO3 ions and then we end up with sodium ions and chlorine ions. What they are telling us in this example here is that we're going to make silver chloride solid. So when we mix all of these ions together, this silver and this chlorine, positive, negative, are going to form an attraction that is so strong that it's better than the attraction of the silver ions for the water. It's better than the attraction of the chlorine ions in the water, and they are going to get stuck together. And when they get stuck together, they precipitate out as a solid. But notice how this is still aqueous. We're still going to have the Na plus and the NO3 minus in solution. So since we have those on either side, NO3 1 minus and NO3 1 minus, they get rid of it. Sodium 1 plus, sodium 1 plus. So really, your net ionic equation here is silver ions plus chlorine ions are going to form silver chloride as a solid. Okay? And remember that all of these are all aqueous in solution. Any of these ions are always going to be aqueously dissolved in solution. Alright? So this is a reaction, and this is going to form a precipitate. That solid is going to precipitate out. Okay? In the second example, we don't form a precipitate, but we do form liquid water. Okay? So again, let's try taking this apart. We have HCl, which we know is going to ionize into hydrogen ions and chlorine ions. We have sodium hydroxide that's going to dissociate into sodium ions and hydroxide ions. Now, what you need to remember, folks, is that any positive ions, so this hydrogen or this sodium, when they're all mixed together in the water, they are perfectly capable of encountering and being attracted to any negative ion. And if the attraction is strong enough, stronger than their attraction to the water, it's going to form a compound. So here, this positive hydrogen is going to encounter this negative hydroxide in solution, and that is going to form more liquid water. Because remember, when we did balancing equations, we told you water really just is HOH. It's a hydrogen and a hydroxide put together. Okay? But your sodium and your chlorine would still remain in solution. Okay? And then in the last one, our last example, everything stays aqueous. So we would actually identify this equation as no reaction. This isn't a reaction, because if you look at the ionic equation, nothing really happened. We started with sodium 1 plus and chlorine 1 minus, calcium 1 plus and calcium 2 plus and bromine 1 minus, and we're going to end up with sodium 1 plus, bromine 1 minus, calcium 2 plus, and chlorine 1 minus. And if you look, sodium, sodium, chlorine, chlorine, calcium, calcium, bromine, bromine, nothing happened. Nothing happened. So that's why that's called no reaction. It doesn't form a solid precipitate, and it doesn't form liquid water. So the question is, how do we know? How do we know which of these things is going to happen? How do we know which of our ionic compounds are going to form an attraction that creates a precipitate and falls out of solution, and which ones are not going to form a precipitate that are going to stay aqueous? How do we know? Well, the answer is we don't exactly. We have to experiment. We have to check. So a lab that we tend to do is this one right here. This is the Solubility Rules Lab, where we take a whole bunch of ionic compounds, mix them together, and look at which ones do not form precipitates and which ones do. And if you look, see how some of these look cloudy, or you've got weird color changes going on? Those are precipitates. Okay, so look at this chart with me real quick. These are your cations on the left over here. So we have lead, copper, silver, iron, barium, calcium, and sodium. Okay, now I want you to notice, sodium, nothing we mix it with, it forms a precipitate. All of these stayed clear. Sodium never, ever, ever forms a precipitate. All right? Now up here you've got your anions. Up at the top, these are your anions. We have chlorine, sulfate, nitrate, phosphate, carbonate, hydroxide, and iodide. All right? And so what we did is we mixed these. So I mixed sodium and chlorine and got no reaction. I mixed sodium and sulfate and I got no reaction. Sodium and nitrate, no reaction. Sodium and phosphate, no reaction. Everything that I mixed sodium with stayed in solution. No reaction happened. So we could very clearly notice here that sodium never forms a precipitate. Never. Doesn't happen once. Okay? Now there's another one I want you guys to look at real quick. I'm going to clear my drawings off of here so that you can look at it a little more clearly. Another one I want you to look at is the nitrates going the other way. Here's another row that is all clear. No precipitates. Okay? It doesn't matter what we mix it with. We mix it with sodium. Sodium didn't form precipitates with anything else, so we wouldn't expect it to here. We mix it with calcium. Calcium does form some precipitates, but not with nitrate. Barium forms a lot of precipitates. Look at that. We got a precipitate here, and we got precipitates here, but not with nitrate. Iron forms quite a few. Here's one. And then all these others over here, there's really only these two that it doesn't form one with. And nitrate is one of them. Silver, lots and lots of precipitates here. Forms one with chlorine, forms one with phosphate, forms one with carbonate, hydroxide. Nitrate and sulfate are really the only ones it doesn't form a precipitate with. So we could very safely say that NO3 never forms a precipitate. Okay? Now if you go, let's look at something else. Let's look at the ones that like almost always do. Alright, for example, lead. Look at lead. The only one in this whole group that lead didn't form a precipitate with was the nitrate. And we just said nitrates never form precipitates. So lead almost always, not quite always, almost always forms a precipitate. Okay? Copper, the first three we reacted with, no precipitate. The last four, all precipitated. So there are several things that copper is soluble with, but there's a lot of things that it's not soluble with. Okay? So as we look at this, same with silver. Oh my goodness, look at silver. Silver only has two things that don't form a reaction. Everything else that silver mixes with seems to form a precipitate. So this is what we do, folks. This is what scientists do. We test it, and we say, what happens? And then we look for patterns or trends, like the nitrate never forming a precipitate, or the sodium never forming a precipitate, or the fact that lead always forms a precipitate unless you mix it with something that never does. And so we've done this over time with all sorts of different things, and we've come up with a set of rules. What things do and do not react, okay? And so this is kind of a chart. I'm going to put this chart in Canvas for you as well, so you have it for your assignment. But this chart is kind of what we have discovered by experimentation. What do we know is and is not going to be soluble? Well, check it out. Remember how sodium was never going to form a precipitate? It's always soluble? It's because it's a group 1 metal. That's true for all group 1 metals. That's sodium and lithium and potassium and rubidium. It's also true for the ammonium ion, NH4. Always soluble, no exceptions. Okay? The other one we saw on there that never seemed to form a precipitate was nitrates, NO3. It's also true for acetates, C2H3O2. They are always soluble, no exceptions. Chlorates and chlorides, ClO4 and ClO3, always soluble, no exceptions. So what that means is it does not matter. It could be sodium chloride, it could be sodium hydroxide, it could be sodium nitrate, it doesn't matter. If it's a group 1 metal, it's going to be soluble every time. Then we get into things that have exceptions. Remember those rows that had like some that were clear and some that were precipitates? These are where we have some exceptions to the rule. For example, the halogens, chlorine, bromine, and iodine. They are usually soluble, but not if you mix them with silver, mercury, or lead. Okay? So silver chloride, like from our example that they gave us here in this first one, silver chloride is not soluble because it's one of the exceptions to our rule. It's a chloride which is usually soluble, but not when it's mixed with silver. So silver chloride would not be soluble. Sulfates, SO4s, usually soluble, but look at this pile of exceptions. So if we go back to our lab chart, and we look at the sulfate row, sulfate with a group 1 metal, going to be soluble. Soluble with calcium, not soluble with barium. Looks like it was probably soluble with iron and silver. Copper, but not with lead. Okay? So you got to watch these exceptions. They're real tricky because sulfates are usually soluble, except for when we mix it with these things. And then cyanides are always soluble, no exceptions. Then we have the ones that are really hard to dissolve, the stuff that's usually not soluble. Okay? So things like carbonates and sulfites, be very careful. Sulfates are usually soluble, sulfites are usually not. And then phosphates. These guys are typically not soluble. They are not going to stay dissolved in water unless you put them with a group 1 metal or ammonium, because those are always soluble. Hydroxides and oxides, OHs and Os, usually insoluble except for group 1 and then calcium, barium, and strontium from group 2. Sulfides, usually not going to be soluble. Anything ending with an S, typically not soluble, except for groups 1 and 2 and ammonium. Okay? So it needs to be one of the more reactive metals, the group 1 or the group 2 metals, or an ammonium ion. Otherwise, sulfides are not going to be soluble. Alright, so let's practice just a couple of these. I don't want to make this video too long for you, but let's just go through a couple of these together. So we have copper and we have nitrate. So let's kind of break that apart. Copper and nitrate. Alright? So if we go to our solubility chart, copper isn't exactly on the solubility, but nitrate is. Let's find the nitrate. There's your nitrate. Nitrates are always soluble, no exceptions. So it doesn't matter what it's attached to. This is going to be aqueous. The second one, we have magnesium and we have carbonate, Mg and CO3. Well, Mg is not a group 1 metal, so let's see where the CO3 is. CO3 is down here, which is usually not soluble except for group 1 and ammonium. Now, magnesium is not group 1 and it's not ammonium, so this is going to be, that happened. Chromates are not soluble except for group 1 and ammonium. Lead is not group 1, so this is going to be a solid. Alright? So those are kind of how these work, and we're going to have you guys practice a few problems in Canvas today.